We'll pick up here on page 87 with example 3. We're skipping part F from example 2 because it works the same as part E. So this says we have a 12-foot ladder that's leaning against a wall. It reaches 10 feet up the ladder. How far is the base of the ladder from the wall? So let's draw a picture. Here we have our building, and then we have this ladder leaning up against the building. This ladder is 12 feet, and we know that it reaches 10 feet up the building. We want to know how far is it from the bottom of the building. The other thing we should know is that any building should be built with the right angle to the ground. So here's our right angle. We go straight across. That means this has to be C. The other two sides can be our A and our B. This is what we don't know, so we'll call that X. So we have A squared plus B squared equals C squared. When we put in our numbers, we have x squared plus 10 squared equals 12 squared. X squared plus 100 equals 144. Subtract 100 from both sides. That leaves me x squared equals 44. We'll take the square root of 44. And that is x equals 6.633. Keeps going. We want to round to the nearest tenth, so the 3 after the 6 tells us to leave it as a 6. And we have 6.6 feet. The area of a triangle is 1/2 times base times height. Now, a way to think about that is that if we have a rectangle, the area is base times height. If I cut it diagonally, I'm losing half of it. So my triangle that's left is 1/2 base times height. So we're going to look for the area in the perimeter. We have inches. So the perimeter is the outside edges again. So here perimeter is 10 plus 13 plus 10.6, or 33.6 inches. Our area is 1/2 base times height. Again, we need to look for the right angle. It's right there. So we're going to use the 8 and the 13. I'm going to write 1/2 as 0.5. And we're going to do that in our calculator, typing those in all at once. 0.5 times 8 times 13. And I get 52 square inches. Over here, the perimeter would be 8 plus 6.5 plus 10.3. And that gives me 24.8 inches. Again, I look for my right angle. So that tells me I'm going to use the 8 and the 6.5. I'm going to put 0.5 times 8 times 6.5. And I get 26 square inches. So now we're going to look at a slightly different kind of problem, example 5. We're going to have to put all sorts of different things together. So I'm going to show you 2 different strategies for these kind of problems where it's not just one shape. So for the first idea here, we're going to look at the outside of this. It's 31 across, and if we add up the 8, the 15, and the 8, we get 31 up and down. This is a square, so the area of a square is base times height, or 31 times 31, or 961 square inches. So that's for the whole thing if there was nothing cut out. But inside here, we have a trapezoid cut out. The top 17 is one base. The bottom, this 10 tells us is the other base. So for our trapezoid, we would have 17 plus 10 over 2 times, and then the height is out here on the edge, 8. So 17 plus 10 is 27, and then we would divide by 2, which is 13.5 times 8, and that gives us 108. Now inside here, the other piece that's also cut out is this rectangle. So that would be base times height. The base is again right here, is at 10, and the height is out here on the side, it's 15, so that's 150 square inches. So the idea with this overall is that we have 961 if it was all completely there, but it's not. This trapezoid is cut out, so we would subtract it, and this rectangle is cut out, so we would need to subtract it. So if I take 961, subtract the area of the trapezoid and the area of the rectangle, I get 702 square inches. We'll skip part B because we're going to do something similar in part C. So in part C, if we put a dashed line right here, or another line right here, we have three shapes. We have this up here, which is a trapezoid. We have this right here, which is a rectangle. And then on the bottom, we have another trapezoid. So let's find the area of the trapezoids first. This base up here is the 14.5. This base right here, it tells us, is 8.5. So we'd have 14.5 plus 8.5. We're going to divide that by 2 because we find the average of the bases. The height is on the outside, 7.6. So 14.5 plus 8.5 is 23. And then we'll divide by 2, which is 11.5 times 7.6. And we get 87.4. Now this trapezoid on the top is the same as this trapezoid on the bottom. They have the same height, they have the same bases, so they'll have the same areas. So now let's look at the rectangle in the middle. Its base, it tells us, is 8.5 across, and the height's out here, so times 3, and we get 25.5. Now in example A, we were taking pieces out, so we subtracted them. We found the whole outside area, and then we subtracted pieces that were removed. But in this situation, we're not taking pieces out, we're putting pieces together. So we'd want to take the 87.4 plus the 8.5 plus the 87.4 and add them together to put the pieces together to get a total area. And if we do that, we get 183.3 square centimeters.